You can form a perfect square trinomial from x squared plus bx by adding b over 2 squared. In other words, you take half of the coefficient of x and square it. That will make that into a perfect square trinomial. So if you have x squared plus bx, you take half of the coefficient of x and square it. That makes it into a perfect square trinomial, and then that factors into the square of the binomial x plus b over 2 squared. Sounds confusing? It's really not too bad. If you have x squared plus 6x, we're going to make that into a perfect square trinomial in the form of a squared plus 2ab plus b squared. So to do that, we're going to take half of the coefficient of x. Half of 6, or 6 over 2, it's going to be 3. Then if you square that, that is 9. So it turns into x squared plus 6x plus 9. So we went from x squared plus 6x to x squared plus 6x plus 9. That is now a perfect square trinomial. That's in the form of a squared plus 2ab plus b squared, and that factors into the form a plus b squared, or in this case, x plus 3 squared. We're going to take this x squared minus 10x and make that into a perfect square trinomial. In other words, we're going to complete the square. So to do this, you take half of the coefficient of x, half of the number in front of the x, or half of negative 10. That is going to be negative 5. So if you take half of negative 10, or negative 10 over 2, that is negative 5. Then we're going to square that. So take half of the coefficient of x, half of negative 10 is negative 5, square it, that is 25, and then you add that on. So it'd be x squared minus 10x plus 25. The 25 completes the square. By the way, that x squared minus 10x plus 25, that is now a perfect square trinomial. That factors into the square of this binomial, x minus 5. So that's in the form of a squared minus 2ab plus b squared. That factors into a minus b squared, or in this case, x minus 5 squared. For this x squared minus 24x, we're going to take those two terms and make that into a perfect square trinomial. We're going to complete the square. So to do that, take half of the coefficient of x. The coefficient of x is negative 24. If you take half of that, that is negative 12. Then if you square that negative 12, that will be 144. So we're going to add 144 on, and that's going to complete the square. That's going to make that into a perfect square trinomial. So 144 completes the square, and this x squared minus 24x plus 144, that is now a perfect square trinomial, and that factors into the square of x minus 12, or x minus 12 squared. So that's in the form of a squared minus 2ab plus b squared. That factors into the form of a minus b squared. In this case, that's x minus 12 squared. There are 4 ways to solve a quadratic equation for x. You could solve by graphing. You graph the quadratic equation and visually see where it hits the x-axis. Those are the x-intercepts. That's solving for x. You could also solve by factoring. You may have to factor out a common factor, or factor it into 2 binomials and then set each factor equal to 0, and then solve those equations for x. You could also solve by what's called the quadratic formula. And you could solve by what's called completing the square. So that's what we're going to go over right now are the steps to completing the square. First step is to rewrite the equation in the form of x squared plus bx equals c. So this is a little different than solving by factoring or solving by using the quadratic formula. In those cases, you want to get everything to one side equal to 0. But when you're solving by completing the square, you want to get the constant term to the right side, everything else to the left side. Then divide all terms by the coefficient of x squared if it is something other than 1. So if you have a coefficient of x squared that is something other than 1, you want to divide the entire equation by that coefficient. Then complete the square by adding b over 2 squared to each side. And what that means is you take half of the coefficient of x, square it, and add it to both sides. That completes the square on that left side. Then factor the trinomial. So when you complete the square on that left side, you'll have a perfect square trinomial on that left side. You're going to factor that trinomial into the square of a binomial. And then take the square root of each side. So that square of the binomial on the left side, if you take the square root of each side, the parentheses and the exponent disappear, as we've seen before when we solve quadratic equations by using square roots. Take the square root of each side and then solve the remaining equation for x. So we're going to start with this one. We're going to solve this by completing the square. X squared plus 6x minus 3 equals 0. First step is to get it in the form of x squared plus bx equals c. That means get the constant term to the right side. So we're going to add 3 to both sides. You have x squared plus 6x equals 3. Next step, divide all terms by the coefficient of x squared if it's something other than 1. Well, that doesn't apply here because the coefficient of x squared is 1. Then complete the square by adding half of the coefficient of x, squaring it, adding that to each side. So take half of the coefficient of x, half of 6 is 3. We're going to square that and add it to each side. So again, half of 6 is 3, square it and add it to each side. Whatever you do to one side, you have to do to the other side. So we're adding 9 to each side. Now on the right side, that 3 plus 9, that is 12. So we have x squared plus 6x plus 9 on the left side. That is a perfect square trinomial because you completed the square. You had x squared plus 6x, and you made that into a perfect square trinomial, x squared plus 6x plus 9. So that factors into the square of the binomial, x plus 3. So that's in the form of a squared plus 2ab plus b squared. That factors into the form a plus b squared, or in this case, x plus 3 squared. Easy way to figure out what goes as that second term in the parentheses is what you got when you took half of the coefficient of x, or half of the b term as I may refer to it. So half of the coefficient of x, when we took half of 6, we got 3. That's going to be the second term of that binomial. So it's x plus 3 squared equals 12. Now get rid of the exponent in the parentheses by taking the square root of each side. So the inverse of squaring is square root. Take the square root of each side. The square root of x plus 3 squared is x plus 3. And on the right side, we're taking the positive and also the negative of the square root of 12. You have to take into account all the possibilities that x could be here. So that's why you have to take the positive and also the negative of the square root of 12. Now that square root of 12, if we're going to simplest radical form, we're going to break that down into the square root of 4 and the square root of 3. And the square root of 4 is 2. So it'd be positive or negative 2 times the square root of 3. Just one step left, and that's to get that 3 to the right side to solve for x. So to get that 3 to the right side, subtract 3 from each side. And finally, that's a lot of work, but we end up with x equals negative 3 plus or minus 2 times the square root of 3. Now we solved that quadratic equation for x. So the story is the same for all quadratic equations. When you solve for x, you're finding the x-intercepts, where that graph hits the x-axis. Now it is radical form, but it does hit the x-axis at negative 3 plus 2 square root of 3, and also negative 3 minus 2 square root of 3. We're going to solve 3x minus 12x plus 6 equals 0. We're going to solve that by completing the square. Well, the first step is to get that constant term to the right side. So that constant term of 6 needs to be moved to the right side by subtracting 6 from each side. If you do that, you have 3x squared minus 12x equals negative 6. Now notice you have a 3 in front of the x squared. If the coefficient of x squared is something other than 1, you need to divide the entire equation by that coefficient of x squared. So we're going to divide the entire equation, or in other words, each term by 3. If you divide each term by 3, you have x squared minus 4x is equal to negative 2. Now we're going to complete the square. So what that means is on the left side, we're going to take half of the coefficient of x. So half of negative 4, that is negative 2. If you square that, that's going to be 4. We're going to be adding 4 on to both sides. So half of negative 4, it's going to be negative 2. Square it and add it to both sides. Whatever you do to one side, you have to do to the other side of an equation. So we're completing the square on the left side, but on the right side, you have to also add that 4. So we're adding 4 on to both sides. Now on the left side, we have a perfect square trinomial. Also on the right, negative 2 plus 4, we'll clean that up first, that's 2. But on the left side, that is a perfect square trinomial. It's in the form of a squared minus 2ab plus b squared. That factors into a minus b squared. In other words, take the square root of x squared, that's x. The square root of 4 would be 2. So that factors into x minus 2 squared. And that is equal to 2. Take the square root of each side. The square root of x minus 2 squared, that would be x minus 2. And on the right side, you have to take the positive and also the negative square root. So it'd be the positive or negative of the square root of 2. Just one step left, and that's to get that 2 to the right side. Add 2 onto both sides. We end up with x equals 2 plus or minus the square root of 2. So that is that equation solved for x, and those are the x-intercepts. This parabola would hit the x-axis at 2 plus the square root of 2, also 2 minus the square root of 2. Now that is radical form. You could go to decimal form if you wanted to. So if we graph this, you're going to see it hits the x-axis at 2 plus the square root of 2 and also 2 minus the square root of 2. Those are the x-intercepts. Remember, the y-intercept is the constant term when it's in standard form. So the y-intercept here is 6. You can see it hits the y-axis at 6. Also, you can see that the parabola opens upward because the coefficient of x squared is positive. What are the solutions of x squared equals 8x minus 1? Well, we can solve that by completing the square. Take that x squared equals 8x minus 1. We want to get the constant term to the right side, everything else to the left side. So that 8x, we can subtract that from each side. And now we have x squared minus 8x on the left, and the constant term is on the right. So to solve that by completing the square, the coefficient of x squared is just 1, so we don't have to divide each term by the coefficient of x squared. It is 1. So the next step would be to take half of the coefficient of x, or half of negative 8, that is negative 4, square that, that's 16, and we're going to add that to each side. That is completing the square. We completed the square on the left side. We took that x squared minus 8x and made that into a perfect square trinomial. Now that perfect square trinomial will factor into the square of a binomial. Also on the right side, negative 1 plus 16, that is 15. So this perfect square trinomial will factor into the square of x minus 4. So where did that 4 come from? Well, you can think of it two ways. You could think of it as that's what you got up here when you took half of the coefficient of x, that was negative 4. Or you could think of it as the square root of 16 is 4. And it's in the form of a squared minus 2ab plus b squared. That factors into a minus b squared. So with x minus 4 squared equaling 15, I want to get rid of the exponent and the parentheses. So take the square root of each side. The square root of x minus 4 squared is just x minus 4. And on the right side, when you take the square root of 15, you have to take into account the positive and also the negative of the square root of 15. Because if you square the square root of 15, that's 15. But also if you square the negative of the square root of 15, that's 15 as well. Solve for x, finish this off, add 4 to each side. When you do that, get x equals 4 plus or minus the square root of 15. So those are the x-intercepts, 2 of them. 4 plus the square root of 15, also 4 minus the square root of 15. That's where the graph hits the x-axis. Some other things to remember about parabolas. The parabola opens upward because the coefficient of x squared is positive. Also, the y-intercept is the constant term when it's in standard form. So if we got that in standard form, if we subtracted 8x and added 1 to each side, the constant term in standard form would be 1. And that is the y-intercept. That's where it's hitting the y-axis. So the x-intercepts are 4 plus the square root of 15 and 4 minus the square root of 15. That's the same as solving that equation for x. Which value for k would make the left side of x squared plus kx plus 49 over 64 equal to 0 a perfect square trinomial? So what value of k makes that left side into a perfect square trinomial? Well, think about that 49 over 64 and how we got that. When you complete the square, you take half of the coefficient of x, you square it, and you add it to both sides when you solve a quadratic equation by completing the square. So to get that 49 over 64, we took half of k, squared it, and added it. So to get what k is, we need to work backwards through those steps. To get that 49 over 64, remember, took half of the coefficient of x, squared it, and added it. So we're going to take the square root of 49 over 64 to undo that squaring, or do the inverse of that squaring. So the square root of 49 over 64, that is 7 over 8. Now again, remember, we took half of the coefficient of x, so do the opposite of that. So taking half of the coefficient of x, the opposite of that, would be to multiply that by 2. So if you take that 7/8, multiply it by 2, that is 14/8. Now that doesn't show up as an answer choice, but that reduces, because each of those are divisible by 2. So 14 over 8 reduces to 7/4. The correct answer here is letter H. You can use the concept of completing the square to change a quadratic function from standard form to vertex form. It says, what is y equals x squared plus 4x minus 6 in vertex form? Name the vertex and the y-intercept. So if you remember, vertex form is f of x equals a times x minus h squared plus k, where h and k would be the x and the y coordinates of the vertex. So it's in standard form right now, ax squared plus bx plus c. It's where everything's to one side equal to y or equal to 0. That's standard form. We want to get that into vertex form. We're going to do it by completing the square. Normally, we'd have to find the x-coordinate of the vertex, then substitute in to find the y-coordinate of the vertex, and then substitute those into vertex form. But here, we're going to use the concept of completing the square. So that x squared plus 4x, those first two terms, we can take those two terms and make that into a perfect square trinomial. To do that, we're going to take half of the coefficient of x. Half of 4 is 2. If you square that, that's 4. So we're going to add 4 on. Now here's the catch. If you add 4 on to that right side, you either have to add 4 onto the left side or subtract 4 from that right side as well to keep the equation balanced. So if you add something onto one side, to keep the equation balanced, you either have to add it onto the other side or subtract the same thing from that same side. So to complete the square here with this x squared plus 4x, we took half of 4 is 2, squared it, we got 4. We added that on to complete the square, and to keep the equation balanced, we're subtracting 4 at the end. So now, these three terms, x squared plus 4x plus 4, we completed the square, so that's a perfect square trinomial. That factors into x plus 2 squared. The square root of x squared is x, the square root of 4 is 2. Those are the two terms of the binomial. And on the end, negative 6 minus 4, that is negative 10. That is vertex form. A times x minus h squared plus k. So here, the x coordinate of the vertex, that's x plus 2 there. The x coordinate of the vertex would be negative 2, and the y coordinate of the vertex would be negative 10. So when I graph this quadratic equation, you're going to see the vertex is located at negative 2, negative 10. You're also going to see that the y-intercept is negative 6. So if we graph that, vertex is negative 2, negative 10, and the y-intercept you can see is negative 6.